Hello, friends. This is a podcast to introduce Section 7.1 in the AP Stats book. So we have just completed probabilities, and we are going to use a lot of what we learned in probabilities to learn about random variables. So to start with, the random variable is any variable, and this is something I've introduced to you earlier in the year. We're going to use the capital X to represent any numerical variable. So we have to decide, so X could be the number of daughters that a family has. X could be the shoe size that a particular person have. The X could be an income. It could be any of the things that we've talked about and all the other examples we've used this year. And we're going to have two kinds, discrete and continuous. And discrete means that the random variable X can only take the value of a whole number. For example, if I flip a coin 10 times, I can only get 1, 2, 3, 4, 5 heads. I can't get 4.2 heads. If I'm counting the number of children that a family has, it's got to be a whole number, 1, 2, 3, 4, 5. It cannot be some decimal. So discrete just means that the value of the random variable X has to be a whole number. So by doing experiments, I can collect data and I can find the probability. And if you look at this first example here, and this is on page 467 in your book, this shows a probability histogram. And the idea you want to get from here is that the area of each bar in the histogram is the probability that that event happens. So in this case, in this example, this is showing that if I pick a random number from either the random digits table or if I generate it on the calculator, each one of these is, remember the expression, equally likely. That's what it looks like in a histogram. And then one of the things we skipped earlier in the year was Benford's law. But Benford's law said something to the effect of the first number in a very long number, it's more likely to be lower number than a higher number. So what you see in this example here is that 1 is significantly more likely than 9 because the area of this bar is bigger than the area of this bar. So these are what the probabilities look like in histograms. Okay, so discrete means that the first number of any number can only be 1, 2, 3, 4, 5, 6, 7, so on and so forth. Now we've already done some coin flipping this year, so we got a heads, we got a tails, we got a heads, we got a tails. So we got one of each. So what you see is that in this case, I got a heads, tails, heads, tails. I got exactly 2 heads, one here, one here. So what this histogram shows is the possible number of heads that I could get if I flip a coin 4 times. And you can see that each outcome is not equally likely. And we've already been through this, because there are actually only one way that you can get 0 heads, and there's only one way that I can get 4 heads. There are four ways that I can get either 1 head or 3 heads, and there are 6 ways that I can get 2 heads. And we should remember this earlier, because there are 2 outcomes, and I'm repeating the random event 4 times. There are 2 to the 4th, or 16 possible outcomes. You see them displayed there. And out of these outcomes, 1 out of 16, all right, this is the probability of getting 0. All right, and that's about what you see here, a little bit less than 0.1. And so the same, so this is 0.25, and this is 0.375. All right, and from the last chapter, we learned that the area of all these bars put together has to add up to 1, and that the probability of the random variable X being 2 is much greater than the probability of the random X variable being 0. All right, second podcast, we're going to do a couple of examples and get you started.